Space, the final frontier, a vast, seemingly endless expanse that has fascinated humanity for centuries. A canvas of celestial wonders, filled with galaxies, stars, and planets that stretch beyond our imagination. But is it as silent as it seems? The quiet, serene view of the cosmos might suggest a profound silence. We often picture astronauts floating in a soundless void, their voices lost in the cosmic expanse. Is this true? Can we really not hear anything in space? The idea of a completely silent space is intriguing, but the reality is more complex. The answer, like many things in the universe, is a bit more nuanced than a simple yes or no. While our everyday understanding of sound doesn't quite apply to the vacuum of space, it's not entirely silent either. While it's true that sound as we know it requires a medium like air or water to travel through, space isn't completely devoid of sound. There are phenomena that can produce sound waves, but they behave differently in the vacuum of space. Imagine standing on Earth listening to the sounds of nature, birds chirping, wind rustling through trees, waves crashing on the shore. These sounds, as diverse as they are, all share a commonality. They need a medium to travel through. On Earth, sound waves travel through the air, allowing us to hear the symphony of nature. But in space, the lack of a dense medium like air means sound waves can't travel in the same way. These sounds, as diverse as they are, all share a commonality. They need a medium to travel through. Without a medium, the sound waves have nothing to move through, rendering space seemingly silent. So, to understand why we can't hear sound in space in the same way we do on Earth, we need to delve into the very nature of sound itself. Sound is a mechanical wave that requires a medium to propagate. In the vacuum of space, there are no molecules to vibrate and carry the sound waves. However, this doesn't mean space is completely devoid of sound. Certain cosmic events like solar flares or the movement of celestial bodies can create vibrations that, if detected by the right instruments, can be translated into sound. Scientists use special equipment to capture these vibrations and convert them into audible sounds, giving us a unique way to hear the universe. These instruments, like radio telescopes, can pick up electromagnetic waves and other signals that can be converted into sound. This allows us to study the universe in a whole new way, revealing the hidden symphony of space. So, while space may seem silent to our ears, it's filled with a different kind of music. A music that requires special tools to hear, but one that tells the story of the cosmos in a way we can understand. The next time you look up at the night sky, remember that space isn't as silent as it seems. It's alive with the sounds of the universe, waiting to be discovered. And as we continue to explore this final frontier, who knows what other cosmic melodies we might uncover. Sound, at its core, is simply vibration. When something vibrates, it causes the particles around it to vibrate as well, creating a ripple effect. Imagine dropping a pebble into a still pond. The impact creates ripples that spread outward from the point of contact. Sound travels in much the same way. These vibrations or sound waves travel through a medium, which can be a solid, liquid, or gas. The denser the medium, the faster sound travels. Think of how sound travels differently through air versus water. You can hear someone talking from across a room, but sound travels much farther and clearer underwater. This is because water is denser than air, allowing sound waves to propagate more efficiently. Now let's apply this understanding of sound to the vastness of space. Space, unlike Earth, is not filled with air like our atmosphere. It's a near-perfect vacuum, meaning it's almost entirely devoid of matter. Without a medium like air or water, there are simply not enough particles for sound waves to vibrate and propagate. It's like trying to create ripples in an empty pool. Without water, the ripples have nothing to travel through. This is why astronauts cannot hear each other in space without the aid of technology. Their voices, while vibrating their vocal cords, have no medium to carry those vibrations to their fellow astronauts' ears. While traditional sound, as we experience it on Earth, cannot exist in the vacuum of space, this doesn't mean that space is devoid of acoustic information. In fact, the cosmos is brimming with various forms of energy and radiation that, while silent to our ears, carry a wealth of information. Space is teeming with activity, emitting a symphony of radiation and energy that we can't hear with our ears. These emissions include everything from the gentle hum of cosmic microwave background radiation to the violent bursts of gamma rays from distant supernovae. This is where the fascinating field of sonification comes in. Sonification is the process of converting non-acoustic data, such as radio waves, plasma waves, or even magnetic fields, into audible sound. By doing so, scientists can transform the silent signals of space into something we can hear and analyze. Sonification is the process of converting non-acoustic data, such as radio waves, plasma waves, or even magnetic fields, into audible sound. This technique allows us to perceive the universe in a completely new way, turning invisible phenomena into audible experiences. Think of it as translating the language of the cosmos into something our ears can perceive. By converting these data streams into sound, we can gain insights that might be missed through visual analysis alone. NASA, for instance, has sonified data from black holes, galaxy clusters, and even the early universe. These sonifications provide a unique way to experience the cosmos, offering a new dimension to our understanding of space. The early universe, with its primordial sound waves, offers a hauntingly beautiful soundscape when sonified. These sounds can help us understand the conditions of the universe shortly after the Big Bang, creating eerie and beautiful soundscapes that give us a new way to experience these celestial objects. These sonified sounds can range from the eerie, almost ghostly whispers of distant galaxies to the rhythmic pulses of pulsars, each telling a story of the vast and dynamic universe we inhabit. Scientists and researchers use these sonified data to study various cosmic phenomena, gaining new insights and making discoveries that might not be possible through traditional methods. By listening to the universe, we can uncover hidden patterns and relationships that enhance our understanding of the cosmos. Moreover, sonification has educational and outreach potential, allowing the public to engage with space science in an accessible and immersive way. Through public programs and interactive exhibits, people can experience the sounds of space, fostering a deeper connection with the universe. As we continue to explore the cosmos, sonification will undoubtedly play a crucial role in how we interpret and understand the data we collect. It opens up new possibilities for discovery and offers a unique perspective on the universe that is both scientific and profoundly human. Section 5: Sounds of Other Worlds, Mars and Beyond. While interstellar space is a near-perfect vacuum, planets with atmospheres like our neighbor Mars do have the necessary medium for sound to travel. Unlike the vast emptiness of space where sound waves cannot propagate due to the lack of a medium, Mars offers a unique environment where sound can indeed exist. This opens up a fascinating realm of possibilities for understanding how sound behaves in different planetary atmospheres. However, the sound you'd experience on Mars would be quite different from what you're used to on Earth. The differences are not just subtle, they are profound. Imagine standing on the Martian surface, hearing the faint whisper of the wind, a sound so different from the robust gusts we experience on Earth. The thin atmosphere of Mars alters the way sound waves travel, making them slower and quieter. The Martian atmosphere is much thinner than Earth's, about 1% as dense. This thinness means that sound waves have fewer molecules to interact with, resulting in a significant reduction in volume and clarity. On Earth, our dense atmosphere allows sound to travel efficiently, but on Mars, the experience is akin to listening through a thick, muffling blanket. This means that sound would travel differently and sound much quieter on Mars. The speed of sound on Mars is also slower, approximately 240 meters per second compared to Earth's 343 meters per second. This slower speed affects not only the volume but also the pitch and timbre of sounds, making them lower and more drawn out. The Perseverance rover, which landed on Mars in 2021, carries microphones that have captured the sounds of the Martian wind. These recordings are the first of their kind, providing a direct auditory experience of another planet. The microphones on Perseverance are designed to withstand the harsh conditions of Mars, capturing even the faintest sounds, the whirring of its own machinery. These mechanical sounds are crucial for scientists to monitor the rover's health and functionality. By listening to the rover's operations, engineers can detect any anomalies or issues that might arise, ensuring the mission's success, and even the eerie silence of the alien landscape. This silence is unlike any quiet we experience on Earth. It is a profound, almost haunting stillness that speaks to the desolate and uninhabited nature of Mars. The absence of familiar sounds like birds chirping or leaves rustling adds to the otherworldly feel of the Martian environment. These recordings provide valuable insights into the Martian environment and allow us to experience for the first time what it would be like to hear the sounds of another world. They help scientists understand the dynamics of the Martian atmosphere and weather patterns. Moreover, these sounds offer a unique way for the public to connect with Mars, making the distant planet feel a little closer and more tangible. The ability to hear Mars brings a new dimension to our exploration, enriching our understanding and appreciation of the red planet. Section 6: The Great Silence and Planetary Symphonies. The vastness of interstellar space, with its near-perfect vacuum, stands in stark contrast to the diverse soundscapes of planets with atmospheres. It's a reminder of the unique conditions that allow for sound as we know it to exist. While the silence of space might seem eerie or even unsettling at first, it also underscores the vastness and mystery of the cosmos. It's a reminder that there's so much more to the universe than what we can perceive with our senses alone. Section 7: Conclusion: A Universe of Sound and Silence. So, the next time you gaze up at the night sky, remember that while space may be silent to our ears, it's far from being a soundless void. It's a place where the laws of physics govern the propagation of waves, where sonification allows us to hear the invisible, and where planets with atmospheres offer their own unique acoustic experiences. The universe is a symphony of sound and silence, a testament to the incredible diversity and wonder of the entire cosmos. Section 8: Subscribe for more cosmic adventures. Did you enjoy this cosmic journey into the world of sound and silence in space? Don't forget to subscribe for more fascinating explorations of the universe and beyond.